whatever is required. So the next algorithm that I wanted to speak about is K nearest neighbors, or KNN. It is a supervised machine learning algorithm as target variable is known, and it is non-parametric as it does not make any assumption about underlying data distribution, and it is a lazy algorithm as KNN does not have a training step. It directly works in real time. It is used for both classification and regression, and it uses feature similarity to predict the cluster that the new point will fall into. I'm sure you did not understand everything over here. So let's take an example. Assume you moved to a new neighborhood. You moved from your current city to a new city, and you want to find friends. You start socializing with your neighbors, right? Some people you will start talking, and some of them you will start seeing that there is a vibe, there is a frequency matching. Okay, they have similar interest as myself, or this person is really hard to talk to. You will start making such assumptions based on the interest, thinking, hobbies. And then you decide from that, okay, these are going to be my friends, my best friends. This is how K nearest neighbors algorithm works. K is a number used to identify similar neighbors for the new data point. So referring to our example from friend circle, if K is 3, that means I will talk to 3 people to decide whom I want to be a friend. If K is 5, I'm going to talk with 5 people to decide which of that 5 will be my friend. So KNN decides, given a new data, which of the neighbors this data should belong to. And choice of K has a good impact on the results. So let's take an example. Let's take an example. So assume there are 3 classes. There is a red diamond, yellow triangle, and green stars. There are 3 classes of ages. I want to determine experience in months. Now a new data came in around 41 years old. A new data came in. I do not know whether this should be pointing to the novice experience category or a medium experience category or a well experienced category. And assume my K is 5 in KNN. If K is 5, from this new data point, find out which are the 5 nearest neighbors. K is 5. So I'm finding 5 nearest neighbors. So 3 red diamonds and 2 triangles came, yellow triangles. Now, naturally, 3 is greater than 2. That means this new data point will belong to red diamond category. This is how I determine where this belongs to, which class this belongs to. This belongs to red diamond because among my K nearest neighbors, majority of them falls on one category. So very simple illustration to understand KNN. So you'd also understand K can never be an even number, because if K is an even number, there are chances of ties, right? There could be 3 on this side and 3 on that side. I'm confused which one to take. So the K has to be an odd number. And now so I skipped one slide here. Now determining K is essentially, there's a score that we will see later called F1 score. So I start with K equal to 1. I increase number of K and identify my algorithm. Which one gives me the highest F1 score? After some K, too many neighbors. So you moved to Chennai from Coimbatore. You want to talk to every single person in Chennai before you find a friend. It's almost very difficult, right? So that is why K cannot be too high. And you cannot decide a friend just by talking to 2 neighbors. You may want to talk to a few people before you decide. So that determining that few is through this matching. Okay, so this is a very simple explanation on KNN. Now let me also brief you about unsupervised learning. We spoke before. A typical unsupervised learning is give some dal, peanuts, and something else to a child, and ask the child to separate. The child will separate without teaching anything. The child knows this is yellow in color, semicircle in shape, whereas peanut is round in shape and brown in color. Very good, right? So that is unsupervised learning. And an extremely popular example of unsupervised learning is clustering, of clustering different objects. Where clustering is used, lot of places. You take a market, business. It is used to characterize and discover customer segments. What type of a customer I have, and when a new customer come, which type of customer he or she is. To do such analysis, I can use clustering algorithms. Or given a new textbook, which cluster this textbook belongs to? Does it belong to fiction, not fiction, technology, and within technology, engineering or science, or all those clustering I can use clustering algorithms. Now to summarize, machine learning algorithms are huge, lot of algorithms. What we have seen is a very few of them, like decision tree, random forest, support vector machine, naive-based classifier, k nearest neighbors algorithms. So we have seen only a few. If we need to see all of them, we need a course to be conducted, not an FDP. But later I will show you. I have a YouTube channel, and I have some of these algorithms in more details. Each algorithm in around 10 minutes each, which may help you understand that algorithm better. So I will share that channel URL later. But with that, let's go to the next step, which is gaining insights from the model's results. Step 4. So let me recap quickly. We initially learned how to gather data, where we will get data from, and then we learn how to clean data, which is the most important step of a machine learning is cleaning the data, which is data pre-processing. Data pre-processing will take a lot of time depending upon the amount of data you have. And then choosing the right algorithm may not be very tough. So once you know, I want to do this, is it a clustering or a classification or a regression problem? First level of decision. If it is classification, okay, I have these algorithms. By doing a research, you will understand these 2 algorithms or 3 algorithms are likely to give me good results. So let me apply my pre-processed data to that algorithm. But cleaning the data may take more time based on the complexity of the problem. Now, once you apply algorithm, how do you evaluate? How do you gain insights? Again, there are a lot of different parameters. We will not go through each of them, but we will go through some important metrics. First and foremost is confusion metrics. It is used for classification problem where the output can be of 2 or more types of classes. Let's say we are solving a classification problem where we are predicting whether a person is having cancer or not. So 0 means no cancer, 1 means person has cancer. Now confusion matrix captures 4 parameters: the predicted positives and negatives, actual positives and negatives. So that are the 2 rows and columns represent. Now the matrix values are true positives, false negatives, true negatives. What is true positive? True positives are the cases where actual class of data point was true and I have also predicted as true. Very simple. The case where a person who has cancer, the model also said he has cancer. That is true positive. What about true negative? A person who doesn't have cancer, model also said that person doesn't have cancer. True negative. What about false positive? A person who doesn't have cancer, but my algorithm said he has cancer. So you imagine corona, someone who is tested positive for corona, but actually he had no corona, some error. Next day he tested, it was correct. We have seen such news a lot, right? False negative, a person having cancer identified by the algorithm as no cancer. That is false negative. So this is the essence of confusion matrix. It may look very simple, but it has a lot of insights. It gives you a lot of insights. The ideal scenario that we want is 0 false positives and 0 false negatives. But that is ideal. That can never be true because after all, machines are machines. We will look for reaching as close to the ideal condition as we can. So let's say in our cancer detection problem example, out of 100 people, only 5 people have cancer. In that case, we want to classify all the cancerous patients as cancer, even with a very bad model. And it will give 95% accuracy. But in order to capture all cancer cases, we might need to end up making a classification when the person actually not having cancer is classified as cancerous. So let's take an example. How do we minimize false positive? That means someone who doesn't have cancer, the algorithm says as cancer. So you take another example. An email is spam or not. 1 is email as a spam, 0 is email as not spam. Now, suppose your model classifies an important email as spam. This happened to me many times, even by Google, by Gmail. I'm not able to see a very important mail, but they are saying we have sent it. Later, I happened to check my spam box and it was there. So an important mail classified as spam, false negative, false positive. In such situation, we may be marking it as move to inbox and it will ask, is it not a spam? We say yes, confirm it is a safe sender. The algorithm is now trying to improve actually. When you put that this person is a safe person, algorithm improves now onwards, this person's email will not be classified as spam. So this is how Google's algorithm works. They continuously learn from your inputs, your actions. Accuracy is something that you popularly hear when you deal with a classification problem, and accuracy is predicted from confusion matrix, first important value out of confusion matrix. So what is accuracy? How well your algorithm performs, right? So a model accuracy can be predicted as total of true positives and true negatives, which means how many of the people are classified as, right, cancerous persons are determined as cancer, non-cancerous persons are determined as non-cancerous over total of them, everything. So ideally, this should be 100. Accuracy should be 100 when everything is classified properly, either as true positives and true negatives over some of them. But in natural cases, there could be some false positives and false negatives. That is where when you read an algorithm on a research paper, you often see 98% accuracy, 80% accuracy, 95% accuracy. That means out of 100 cases, 95 will be true positives and true negatives. 5 will be false positives and false negatives, which is natural to an algorithm. And another important value we get out of confusion metrics is precision. Precision is a measure that tells us what proportion of patients that we diagnosed as having cancer actually had cancer. So true positive divided by true positive plus false positive. In our cancer example, assume 100 people with only 5 people have cancer. Let's say our model is very bad and predicts everyone has cancer. The precision here will be 5%. On the other hand, if it treats say 4 people have cancer and then or 6 people have cancer among 5, then the model accuracy is quite high, precision is quite high. There is also a measure that we derive out of confusion metrics, which is recall or sensitivity. Recall is a measure that tells us what proportion of patients that actually had cancer was diagnosed by the algorithm as having cancer. So my intention is to avoid false negatives. So true positives divided by true positive plus false negative. And measuring many of them will be very tough. So there is a measure that combines both precision and recall together, which is F1 score. If you remember KNN algorithm, we used F1 score to determine which is the best value for K. So what is F1 score? Let's take precision. Assume there are 3 true positives and 97 false positives, 0 true negatives and false negatives and 0 false true negatives. Precision is 3 out of 100. Recall is 3 out of 3, 3 plus 0. Now F1 score will give a, so if you take a simple arithmetic mean of precision and recall, it is somewhere instead of 3 and 100, it will become some 50 or something, which is quite not representing the precision and recall correctly. So F1 score is a harmonic mean, like two, arithmetic mean, geometric mean and harmonic mean. F1 score depends on the harmonic mean, 2xy divided by x plus y. So 2 times 3 times 97 divided by 3 plus 97, which will give a more realistic value of the overall effect of the precision and recall. And that is F1 score. 2 times precision times recall divided by precision plus recall is F1 score, which is an important measure. See here 5%. So even though recall was quite high, the fact that precision is this one is much more evident from your F1 score. So confusion matrix gives you several beautiful insights, including accuracy, precision, recall, and many others which we did not see. So we can use a simple Excel sheet even to find out all these values once you feed in your true positives and true negatives and all other things. This is an example. Just fill in these formulas into your matrix, into your Excel sheet, and you can get all these values. Or you can programmatically calculate all these using Python or R or any other language. Now, precision, recall, and accuracy and all others are very good measures for classification problems. For regression problems, like given a weight, determine height, or given a height, determine weight kind of problems, what we find, if you remember our first example 101, what we measured is the root mean square error. How much it deviates from the equation that we gave, the error value in it. So we can measure the root mean square error. So I calculate the error and then predicted minus actual the whole square, sum of that divided by total number of samples and square root of it, root mean square error. And the lesser the value of root mean square error, the better my algorithm is. I'm just stopping here because there are too many different parameters that people typically consider, but I gave you the most important highlighted ones. Now the last step is, once you have insights gained, how do you visualize? I'm going to just flash through all these visualization techniques. You can see that there are different algorithms for these visualization techniques back in your libraries, in your Python library or R library. Most of these visualization techniques are just single line function call. You don't need to write anything important. You can simply call that function with your values. You are going to get the plot ready-made. Classification report. One of the best important classification report is your confusion matrix and class prediction error. For example, among all things that are classified as apple, how many of them were actually kiwi, orange, and banana, and how many of them were really apples? So class prediction error. Then the precision recall curves, confusion matrix. So the example we have seen in confusion matrix was 2 by 2 because it was a 2-class classification. But when you have multi-class classification, the matrix will be much bigger in size. And if you take regression visualization, the prediction error, the root mean square error, or residual plots, and there are a few other metrics like alpha selection and things like that. There are also clustering visualization, which we did not discuss. So the elbow method, if you remember how we determine the K value is an elbow score. So I have number of Ks here and then I determine which K gives me the best answer. And there are many other visualization like intercluster distance maps and text visualization when your input is all in terms of text. And how does the clustering works? We can use some special plots for text visualization, feature importances, which features are important than which other features. And all of these have libraries in scikit, if you take Python as an example. Now let me give a brief introduction to artificial neural networks and deep learning. Have you ever wondered how your brain recognizes numbers or letters, digits? That is nothing but all the millions of neurons that are connected within your body. which the moment an ant bite on your leg, your brain understands, right? And that is because the neural networks within your body are connected. They are communicating messages in between. Now, computer scientists, we borrow that idea and we started working on artificial neural networks. So simulating human brain, how the networks are working. We also have similar various input features of, say, a cat, the fur and whisker and ear and all other parameters. We evaluate and add through some functions, connect them like how the neurons are connected, and then give outputs. That is the basic fundamental idea behind human brain neural networks. The structure of a neural network is very simple. You have inputs and a weight for each input, how much each input is valued, and they are all given to a bias, an activation function, and based on that an output comes up. So how a perceptron and a single neuron, a perceptron works, all the inputs along with the weights are multiplied and you get an output, a value x1 times w1 plus x2 times w2, whatever, and that output is classified into say 0 or 1 if it is a two class classification for a neural network. A simple example, very simple example. And then you start adding layers. I have first layer where I did that input types weight, and each of that answer I start adding into forming multiple hidden layers. So maybe first layer, my aim was to identify whether its ear is straight or not. Second layer, whether it has fur on the body. Third layer, how it walks. Fourth layer, the color and things like that. Each layer I identify something and finally determine the output. That is where we start adding multiple layers, means multiple different features are being examined to understand how the network works. And there is an activation function which is used for non-linear complex functional mappings. So you have multiple inputs, you have summed it up. How do I determine what should be the output chosen? That is determined typically by your activation function. There is also a feed forward neural network, like data flows in one direction, it doesn't flow back. There is also feedback network where the some stages of some layers output will be feedback into previous layer so that your algorithm gets improved over and over. With that small introduction to artificial neural networks, what is deep learning? Deep learning is an extension of machine learning, which is a subfield of machine learning, which is concerned with algorithms inspired by the structure and function of the brain, called artificial neural networks. So in machine learning, someone will manually do feature extraction, then you put it into classification algorithm, which will tell whether this picture is car or not. If it is deep learning, you just simply pass the images of car into your deep learning algorithm. The algorithm will do feature extraction, feature minimization, or feature reduction, dimensionality reduction, classification, everything through different layers, and it will give you an output. So that means your data pre-processing steps will be minimal or nothing if you use a deep learning algorithm. But if you use a machine learning algorithm, you have to do that pre-processing steps by yourself. So since everything is done by machine needs more input data. That is the other side of deep learning. If I can train a classification model with 1,000 images of cars, maybe for training a deep learning model, I may need 10,000 images of car, because the algorithm has to learn by itself which feature to extract, which feature to eliminate, and then how to classify everything by itself. So if I take all these three, artificial intelligence is a broader, most umbrella within which machine learning comes, and then within which deep learning comes. It's a subset. They are not, none of them are different from each other. They all complement each other. So deep learning is nothing but an extension of your artificial neural networks, which we have seen. So let's take a simple example. How do you recognize a square from other shapes? First thing is to check whether the figure has 4 lines. That is one layer in your neural network. Then the second layer is, we further check if all layers are connected and closed. If that is also true, the next step is, next check is, Are those lines equal in size and perpendicular? All this together makes a decision that this is a square. If any of them fails, it could be circle, rectangle, or triangle, or anything. So for a deep learning algorithm, each of these will be different layers, different ways it learns, each learning in different steps. So we took a complex task of identifying a square and broken down into simple tasks by checking whether it has four sides, are they perpendicular, are they of equal size, and so on and so forth. So that is such a simple thing that our brain can understand. Now, what about a cat? There are multiple layers that are needed to identify whether a given image is a cat image or a dog image. Okay. Where do we use application machine learning, deep learning? Lot of examples. Your companies, all your popular companies where you go and shop or go and socialize uses it for recommending. I'm sure you have seen people you may know feature in Facebook, or customer who bought this item also bought feature in Amazon. Jobs you may be interested item in LinkedIn, recommended videos in YouTube. Everything comes from deep learning algorithms. So recommendation engine, for example, there are two types of filtering methods that are used in recommendation engine. One is collaborative filtering, recommendation products based on similar customer. If my purchase pattern is similar to my friends, someone else's purchase pattern, what I bought can be recommended to me. That is collaborative filtering. Whereas content filtering is, I like and bought this item, so I may like this item. Based on what I bought, it is trying to recommend. Then there are text sentimental analysis, which is done using deep learning algorithms. There is a sample code here. You can go and try out how sentiment analysis works. There are chatbots. Chatbots are seen as one of the pillars of next generation UIs, right? You go to many websites, a chatbot will pop up saying, I am Claire, I am Elena, I am Ganesh. How can I help you? And then you start filling your input. It will give you next steps and finally choose the answer. And they need lot of data science, a lot of data science, because they deal with massive amount of data, how people communicate. It cannot be built by a simple decision making algorithm, right? Because different people may write English in different ways. There could be spelling mistakes, grammatical errors, wordings, synonyms. So your algorithm has to process huge amount of data, do data analytics, apply machine learning algorithms to finally form this AI solution of chatbot. Image recognition used by your social media, marketing research. So let me take this extended example of top 10 machine learning examples in medical field, because they are so important. Since we are dealing with, I'm not going to go through every single text in these slides, but the title alone will give you an answer. One of the most important application of data science, artificial intelligence, and machine learning is identifying diseases and diagnosis. How to identify a disease given various predictions. So given I have cold for 3 days, I have throat pain for 2 days, I have difficulty breathing for 2 days, and mild fever one day, can I determine this as corona? Is a example. Or drug discovery and manufacturing. Given similar symptoms have this medicine for that particular disease, can I advise, can that algorithm advise this particular ingredient for making a new corona vaccine? Or given the image of X-ray, can I determine whether this person has corona based on the X-ray conditions of chest, having cold and other things from the chest impression? Or personalized medicines, behavioral modification, this is for cropping up in the fields, or cancer prevention and identification, patient treatment, etc. Smart health records. So the health records are available at one place and I go to a different doctor. The algorithm can tell, without showing the records which are private, algorithm can predict and tell, this is how the history looks like. This is the type of user he is. So clustering or segmentation can be done. Clinical trial and research. crowdsourced data collection, and radiotherapy, outbreak prediction. The best example we spoke in the beginning of today's session, the corona outbreak prediction done by Blue Dot Company is an excellent example. There are a lot of interesting articles. If you simply Google, you will get many. Here are some of the ultra modern medicine examples of machine learning in healthcare, or 7 applications of machine learning in pharma and medicine, artificial intelligence and deep learning for medical diagnosis, potentials of artificial intelligence in healthcare. They are all recent articles if you see, and they are all very good samples to start with. And I took healthcare as an example because it is the current day demand. But if you take any other sample, I'm sure for each type of a field, you will get plenty of samples. Some resources for you to start. Where do you start? Having learned so much of basics, I learned basics of machine learning, deep learning, artificial intelligence, data science, how they are related and different from each other. We learned a lot of this. Where do I start? There are plenty of resources available in Google, and that is also a blessing in disguise, right? When there are a lot of resources, I'm confused where to start. So this is one website, elitedatascience.com, has a lot of machine learning projects for beginners. So if you want to suggest to your students, if you are a faculty, these are some of the algorithms or links where the student can practice existing algorithms to get familiarized by himself or herself. An example of that is see predicting stock prices. That link gives you a Python code for predicting stock price and R code for predicting stock price. So it's now up to you which one to choose based on your programming language familiarity. And then they say different data sources that are used by that algorithm for predicting stock price. So you have all resources to start with to learn how it works. And later you can extend it to your other innovative and new algorithms. I started the same way. Let me also just show you. Google Colab. I'm not sure if you're familiar with Google Colab. If you're thinking, how do I write and run a algorithm, machine learning algorithm in my computer, there is nothing to install currently. There is nothing to set up, nothing to install. You simply, as I did just now, you simply search Google Colab. With your Google account, Google gives you a free UI to start writing your code, Python code for running Jupyter type of, I'm sure you have heard of Jupyter, but Jupyter and Anaconda are all you need to set up on your computer, and Colab comes with everything pre-set up. So you see here, I start inserting a cell, a code. I can write commands as text in between comments, and then start filling up everything that I need to fill up. Once I filled up everything, once I start filling up, I can also start testing. There is a runtime here. I can run. So it will take my code one by one. It will run, and it is showing this run and everything free. You remember, I am trying to connect now. This is trying to connect and giving me a server. Once I get a server, it will run. So it is initializing, connected, and see each cell by cell it is running, and I will get my output for the given sample. All of them are ran already. Now I am at this step. It is asking me to upload a file. I'm not going to do that because this is not our focus. But once I upload a file, it is going to do the next steps and finally give my answer for random forest. So, and again, how did I get this? It is as simple as typing Google Colab, and then I get the link, and then I start. If you have existing Jupyter notebooks, you can use that. You don't need to populate everything from scratch. If you get a .ipnb file from Google, you can simply upload and then start running. That is also the beauty of Google Colab. And the best part is Colab stands for collaboratory. So I can share. Once I start writing, I can share with my friend or whoever, and then people can collaborate. Collab means collaborate. So I can start collaborating. See, there is a huge, I have uploaded a file, a big diabetes database file from Google, and see how the decision tree looks like, quite big, right? And I have to still do it more. So it's very easy. There is nothing to set up. Don't worry about such things. Leave that to Google. You can start doing it. There are other places like if you go to Analytics Vidya, there are huge amount of projects. One of the first projects I tried is also Iris data, Boston housing data. All these are something I tried myself to learn machine learning. And then there are other intermediate and advanced problems where they are trying to solve. So they comes with ready-made core. So there is not research here. It is more of learning. Later, once you are comfortable with those, you can start applying it into your own research. Where do I start learning machine learning? There are a lot of courses online. There are courses specific on machine learning, deep learning, specialization courses. You can also take not only Coursera, Udemy, and all of them. There are also available videos available on Google, YouTube. So it's only a matter of your vision and time that is required to go and spend your time learning this. Some of them are very cheap, say like 770 rupees with 76,000 people giving a total of 4.5 star. I think we can believe that, right? It is quite professional. So we can go through by a very nominal fee. Sometime Udemy and all offer them for even lower prices like 200 rupees, 300 rupees, or for free also. And Coursera courses are free always, just that you don't need get the certificate. I don't think the certificate is required. Learning and knowledge and applying them to do projects is more important. So you can always do that. And for getting latest news and tutorials, I generally follow these things. Geek for Geeks, developer.google.com/machine learning, Medium. These are some links that I found very interesting and useful. Some final notes before we wind up. How do we identify good problems for machine learning? Problems, focus on problems that would be difficult to solve with traditional programming. For example, to determine grade of a student given marks, do we need machine learning? I don't think so, because a simple Excel sheet with some formula within the Excel sheet itself can give me the grade by supplying grade conditions, right? On the other hand, a smart reply, a smart response on Google or a smart tagging, face recognition and tagging of people on Google Photos are good examples that Google identified as a problem, good fit for machine learning. So you should be first determining whether my algorithm is, whether my problem is a real good fit for machine learning. Just that machine learning came, everything cannot be done in machine learning. They can be done much better in a normal algorithm. So know the problem before focusing on data. Don't think about what data set should I start with. Think about what problem that I want to solve. Once I know the problem to be solved, I can always go and look whether my data is there, whether data set is available. ML requires a lot of data, relevant data. And you should not try to make ML do the hard work of discovering which features are relevant for you. As long as you are applying machine learning, pre-processing is your duty. So based on your algorithm, based on your need, you should determine what feature is relevant for you and aim to make decisions and not just predictions. Hard machine learning problems, clustering, even though it looks simple, is quite hard problem. Or anomaly detection is quite hard because if you take this as a classification problem, majority of my input data, historical data will be not anomaly. Only a few are anomaly. So your input data is really biased. From that, you have to start and then detect anomalies, which is quite tough. Causation. For example, ML can tell you this is what it is, but ML probably cannot tell you why this is what it is. Why this is uh, belonging to cluster 1 or cluster 2, or why this is belonging to class 1 or class 2. It can tell it belongs to this class, but it may not be able to tell you the why part, causes. No existing data is another challenge. So in fact, if you remember, I had that Mudra classification problem. My vision was I want to solve hand gesture recognition for Kathakali using deep learning or hand gesture recognition. I understood that is not a trivial problem, so I have to apply machine learning or deep learning. And then I searched for data. Uh, no data available. There was not even a single data set available for Kathakali hand gestures. You will find hand gestures on dumb and deaf communication or hand gestures for Bharatanatyam hand gestures for some Western dance, but not for Kathakali. They are different. So we built data set. Since there was no data, it was a challenging problem for me for a long time until I found one student who was willing to make a data set along with me. Then later, I wanted to identify, given an image, can you identify the character? This is to be identified as Krishna wearing blue color with a peacock feather on top. Or this is to be identified as a beautiful woman. And all these are one character, actually myself in all these different characters. But now by seeing the color, seeing the combination of image, can the algorithm determine? Again, data set was a problem, no existing data. So we built a data set, we have made an algorithm, a deep learning algorithm, convolutional neural networks, which help me get 70% accuracy. First round 70% accuracy is not bad. So hard ML problem is one reason is no existing data. So what did we learn today? We learned uh, the basics of artificial intelligence, data science, introduction to machine learning, and various steps involved in processing data, right from gathering data, visualizing, gathering data, pre-processing data, applying to the right algorithm, measuring the performance, and then visualizing. We have seen each step in little detail, not in full detail, including some algorithms in brief. We have also seen what is deep learning, and then how what are some of the difficult things that we can see for machine learning, the hard problems with machine learning. So I hope I was able to give you a very simple high level overview of various concepts involved in machine learning, deep learning, and data science. Some of these algorithms which we spoke about are in detail given in some of my videos here. So it is quite easy. The URL bit.ly/ml playlist Ganesh. If you go that, you will be able to see a playlist of 18 videos. Some algorithms are given in details. So feel free to go through them and subscribe, listen to the video. You can give your comments and feedback on any of those video that you want to know about this particular algorithm, or this is not explained rightly, anything that you feel right. And I can be connected through LinkedIn through my Ganesh and Iyer, my name, or I have a website, http or https://ganeshandiyer.com. My email is here. There are two, ganesh@ganeshandiyer.com, easy to remember. If you want more memory, ganesh.vigneshwara@gmail.com. I'm open to questions in case you have any questions for next 5 minutes. Yeah, so some people are asking about sharing files. So maybe along when I share my PPT, I will share one or two examples of my samples of these Google Colab files too, which may help you. Make sure before you quit the session, please go and fill the feedback. Saravanan sir has shared the feedback link in this sheet, which is extremely important for me to understand where I stand and how was my flow of presentation and how was it useful? I strongly encourage if you can give some suggestions here in case you have any suggestions. Yeah, there are people who have tried using deep learning using audio recognition for identifying ragas for Carnatic music. I'm sure you will be able to find out some of them samples, and I'm sure there will be much more scope for improvement. It will be a wonderful area. Yeah. Some example in educational institution. There are a lot of examples. If you take educational institution, like you want to cluster the students based on their marks, you want to cluster them into high performers, medium performers, low performers, slow learners. Then you can do that techniques using your current data simply to understand where your class looks like, how your class looks like. Uh, so that is a good example of how you can apply, or the kind of subjects, if you have elective subjects, the kind of subjects which are more popular than less popular, and why that is popular. Maybe by conducting some feedback survey, you will be able to identify and process the text so that you will be able to identify why some subjects are more preferred by students. Is it only a faculty, or is it the topic, or whatever? You will be able to identify a lot of use cases. I am just telling you one or two use cases that came out of my mind just now. Uh, so there is also, how do we set probability value? I'm not sure for which type of a algorithm you're referring to. So it depends on algorithm essentially. So for a naive-based classifier, maybe the probability values are given based on frequency of usage of words. So that is actually done using statistical analysis itself. You initially analyze each word, how many times it repeat, and then apply a probability to it versus some other algorithm. So it depends on algorithm. There are textbooks only on probabilistic machine learning. I would suggest you to refer to that. Any other questions or any feedback? Anyone who would like to open up the mic and just say one or two lines about the session today? Anyone?
Thank you, sir. Dear
Yeah.
participants, our expert is waiting. So if you have any doubt in this recording session, you can
Or any
unmute your mic.
comments, or any
Yes.
comments whether you met your expectations. Is this what you were thinking on first day of your 5-day FTP? Anything?
Yes, yes.
Hello, sir.
Yes.
Sir, I'm Dr. Sandal. I'm working as associate professor in Andhra.
Okay.
Sir, I have gone through your session, sir. It was touched all the parts of the basic of ML and data science.
Okay.
The session was very useful, sir.
Thank you very much. Thank you.
Yes, sir. You have given the very much introduction about all the algorithms used in machine learning, and it was very useful, sir. Thank you, sir. Thanks for your
Thank you. Thank
introduction.
you very much. Thank you.
Yes, sir. Good afternoon, sir.
Yeah. Good afternoon.
Sir, session is really excellent and really appreciate the efforts put by you, sir.
Thank
Uh,
you very much.
I like the difference between the supervised learning and unsupervised learning, and
Yeah.
the classification and regression examples, and
Thank you.
the sir, you explained very deep. That is what is actually the AI, deep learning, machine learning, and all these things, and data science. So, thank you, sir, for all this.
Thank you very much. Thank you very much.
My pleasure, sir.
Yeah. Okay. So if there are no more questions or doubts, let me just share these links on this in case you wish to get in touch with me anytime. So thank you very much once again to the college, the management for giving me an opportunity to share some knowledge that I have. And I'm quite happy that people are also happy about the session. So please don't forget to give this feedback. Thank you very much.
Thank you, sir. Thank you. Thank you very
Yeah.
much for.
Yeah. So Sarwan sir, shall I quit now?
Yes, sir. Thank you. Thank you very much,
Okay.
sir. Once again, I will thank you.
Yeah. Yeah.
Dear participants, kindly fill this feedback form. This is mandatory for your attendance as well as feedback. Okay, sir. Thank you very much, sir.
Okay. Bye.
Bye, sir. Bye, sir. Thank you.
Sarvam sir, when the next session will start?
Yes, sir. Next session start by 2:20 p.m., sir. 2:20 p.m. Nearly 1 hour we can take break for lunchtime. 1
Okay,
hour
sir.
we can take, sir. 2:20 exactly we can join, sir. Next session.
Right, sir.
Okay, sir. Okay.
Right, sir. Thank you.
Sir, you can stop the recording also.